this discussion. That will be the, suppose you toss a coin, you can get tail, etc., tail and then head. So here what happens is success. So if I call this success or head at kth trial. So what is the probability of, so I'm going to denote this by a new random variable. So y represents the number of to the first success. So we are talking about tossing a repeated coin, but let's say we are interested in a success or a head. So what is the probability that y equal to k? So y is of course a random variable because we don't know how many trials it would take. So that would be the same as the probability of t, etc., t, then a head. So these are independent events, and there are q minus 1 of them multiplied by. So we can write it as p q k minus 1. K goes from, could be 1, 2, 3, etc., up to infinity. So because it looks like a geometric series, this is a geometric random variable, known as geometric random variable. So we could generalize this notion into success at the so let's say C requires number of trials required for let's say n successes. So question is, what is the C equal to k? So what that means is, so you have the last one is a success, and you want this to be the nth success. So let's say totally you need k trials. Then in k minus 1 trials, you need m minus 1 successes. So this is n minus 1 successes in k minus 1 trials. But that's simply binomial, right? So you can say this is a binomial with the parameters binomial with the k minus n minus 1 successes in k minus 1 trials, followed by a coin toss. So the probability of the first one, so it will be product of two probabilities. This probability is easy. Probability of head is small p. Here it's going to be a k minus 1 trial. So this is k minus 1 and n minus 1 successes. So it is this. P to the power n minus 1, q to the power this minus this, that's k minus n. Multiplied by small p. So if I multiply everything, this will be k minus 1, choose n minus 1, p to the power n, q to the power n minus k. And the number of trials k has to be at least n or n plus 1, etc., all the way to infinity. So this random variable, so this is probability of z equal to k, the number of trials required. So this is known as negative binomial. So we can use this last one to analyze an interesting problem. So let's say in a World Series, winning is decided by the team which wins the 4 games in, let's say, for the team to win the fourth win in among n games. So n is usually 7. So let's consider the 4-7 case. So the question is, what is the probability of, find the probability of winning the series. So let's answer this quickly. Let me, let Sk represent when you play k games, the 4th win comes in the kth games. That's exactly this here, because number of trials required for n successes. N is 4 here. So here is his number of, so k trials required for n successes. So in k trials you get 4. So xk is going, we know probability of xk. That's going to be precisely this expression with n equal to 4. So this is k minus 1, 3, p to the power k n, which is 4, q to the power k minus, this is n minus k. I mean k minus n. K minus n, right? K minus n is 4. But to win the game, so a team can win the series. Of course, here P is whichever team we are looking at. So let's say team A wins the series. That means team A has to win, either x4 has to happen, or x5 has to happen, or x6 has to happen, or x7. It could win by winning the first 4 games, or win 4 games in a series of 5 games, or win 4 games in a series of 6 games or 7 games. But these are mutually exclusive. So probability of a team winning the series is sum of probability of xk, k equal to 4 through 7. Then you substitute this and you get the answer. So k minus 1, choose 3, p to the power 4, q to the power n, k minus 4. And k goes from 4 through 7. You can replace k by n if that's what. So the question is, what is p? So knowing the statistics of A, we may know that p is in this case, which is probability of A winning any game, is something like, well, let's say 0.51. They have slight advantage. So you plug in that number. Q is 1 minus p. Everything else is known. And that number will turn out to be slightly better than this as a rule. Of course, if you play 99 games, then the interesting thing is if you plot this, you can convert this number will turn out to be close to 1. So slight advantage. So essentially this will have a graph like this. So this may be with the n equal to 7. So I'm plotting here this probability. Let's call it PA. But if you play 99 games, you may get a situation like this. So this is the green graph is for n equal to 99 games. What that means is, so that will be something like this. What that means is the team with the slight advantage will turn out to be a sure winner. Whereas if you, of course, for logistical reasons, in actual game you can't play 99 games, so you play 7 or 9, whatever, usually 7. And then 0.51 may translate into 0.57 or something like that. I don't remember the exact number, but you can compute this.